Today's lesson is how to use function tables. Now, you might not realize that you actually do know what a function table is. Maybe you've heard it described like this: an input-output table. When you're thinking about input and output, just think in and out. And you put something in and something else comes out. We can picture it like this. Go ahead and write this down and draw this out. Think of this as like a pipe. And you can start out with some materials. You can put those materials in, and depending on what goes on inside the pipe, something else can come out. It's the same way with math and with numbers. If you start with the number 5 and you put on the inside of that pipe is a number plus 2. The 5 goes in. The 5 is that number. It gets changed because you add 2 onto it, and what comes out would be a 7. We could call that first number that gets put in x, and then the function would be the rule, and the number that comes out could be the y. Now we can use a table to keep track of what's going on with x and y for a certain function. So what if it was n plus 2? We could create a table to keep track of that. And we could try out different numbers for n and see what happens. So if n was 0, n plus 2 would be 0 plus 2, which would be 2. If n was negative 1, which on a number line would be right here, n plus 2, 1, 2, would be positive 1. If n were 2, then n plus 2 would be 4, and just for the fun of it, let's do some more negative numbers. If n were negative 2, that means starting right here on the number line and hopping 1, 2, then n plus 2 would be 0. Now the cool thing about this function table or this input-output table is that it can be graphed. If we decide that maybe our first column for n is going to be our x-axis, and our second column, n plus 2, maybe could be the y-axis, we can use these as if they were coordinate pairs. 5 over 7 up. 0 over 2 up. Negative 1 over to the left and 1 up. 2 over 4 up. Negative 2 to the left and 0 up. Ran into my number line there. So, using what we've learned in previous lessons about plotting ordered pairs on a coordinate graph, let's see what we can do with these. Now I'm going to erase that number line that I used to help me with my negative numbers, but you can go ahead and keep yours. And right below this, or maybe off to the right-hand side of your paper, wherever you've got room, go ahead and draw a Cartesian graph with all 4 quadrants. Remember, quadrant 1 is all positive land, and then we've got quadrant 2, 3, and 4, which each go into negative land. Use your notes from previous lessons to figure out how to put numbers on these, and realize that based on our data doesn't really matter. We will need to go to 5 over and 7 up, so that should help you as you plan where your tick marks are going to go. Try to do that on your own, press pause, and then check back with me once you think you've gotten it. All right, hopefully your Cartesian graph looks something like this. And we can plot each of these ordered pairs as a point somewhere on that grid. So 5, 7, if 5 is along our x-axis, that's along the left and right horizontal axis, and 7 is along our up and down vertical axis, our y-axis. So based on what you've learned before, try to point these plots on your own, press pause, and check back with me. Notice anything? Hopefully you noticed that these kind of have created a pathway. And we always will have a straight line type of graph when we ever have a function like this. So we can use an input-output table with a specific function, and we can graph those. Now to finish our graph, we need to connect the dots. Ideally, you would use a ruler or a straight edge to connect those dots, and it would be perfectly spaced out. So if you've got a ruler or a straight edge and you can perfectly connect those dots, go for it. Now, the really cool thing about using a function table or an input-output table is we could keep this going. We could keep trying numbers for x, putting them in the pipe, the n+2 pipe, and seeing what comes out. And we could keep going along the x and the y axis. So really, this graph that we have is only a small part of the entire line that could go on in both directions for an infinite amount of time. We could keep plugging in numbers until our arms turn blue and fall off, and we will still be along this pathway for this rule or function.